Auzubillahiminash-shaytanir-rajeem. Bismillahir-Rahmanir-Rahim. Our next topic in set theory is lattices. Actually, it is in partially ordered sets chapter related to that concept. Okay, what is a lattice definition? Let A be a partially ordered set if every doubleton, means if every two elements in A has the supremum and infimum, then A is called lattice. Simply, as you all know that supremum is least upper bound and infimum is greatest lower bound. Now you know how to find the upper bounds and how to find lower bounds, and you also know that how to find the least and greatest element of that class. So if every two elements has a supremum and infimum in that set, then that partially ordered set actually is called a lattice. Supremum, if we define supremum of two elements, then it is denoted by this symbol x sup y, and generally infimum of two elements is denoted by x inf y, and you can also call it x join y and x meet y. The expression, okay, if A and B are arbitrary elements of a lattice. Okay, now for supremum and infimum you need to define the supremum and infimum according to the set separately. If set of numbers, if there are set of numbers and you have an order relation less than or equal to, you need to define supremum and infimum according to the set of numbers, and similarly it must satisfy the condition of supremum and infimum, means lower bound of, if we say that 8 is the supremum of two elements 8 and 16, then it means that 8 is the upper bound for 8 and 16 and 8 is the least upper bound for both 8 and 16. We'll do it in example. Okay, now for this supremum and infimum terms, if A and B are arbitrary elements of a lattice, then A must be preceded by या A less than or equal to A sub B. A must be preceded by A sub B means यही इससे है, मतलब कि सुप्रीमम से आपका सुप्रीमम जो है वो आपका इस एलिमेंट से हमेशा ग्रेटर रहेगा. ग्रेटर इन द सेंस, अगर आपके पास लेस देन आर इक्वल टू, यहाँ पर आपके पास ये प्रीसीडिंग सिंबल है, ठीक है, इसको लेस देन आर इक्वल टू पढ़ें, ये प्रीसीडिंग सिंबल पढ़ें, बट इट इज़ नॉट डिफाइंड नहीं है. कुछ केसेस में जैसे आपने देखा ऑर्डर रिलेशन के केसेस में इट इज़ डिवीजन भी हो सकता है, समटाइम्स ये लेस देन आर इक्वल टू भी होता है. और इन टर्म्स ऑफ सेट्स की जब हम बात करते हैं तो ये सब सेट्स का जो आपके पास सिंबल है कंटेनमेंट सिंबल, तो वो भी आपके पास हो सकता है, ठीक है. उस केस में आप फिर कहते हैं ए सेट इज प्रीसीडेड बाय ए सुप पी, जो भी आपने वहाँ पर सुप्रीमम डिफाइन किया होगा. सो दीज आर द डमी, सो जनरल वर्ड्स. सो यहाँ पर ये वो लेस देन आर इक्वल टू है, ये प्रीसीडिंग वाला सिंबल है जो आपके पास ऑर्डर रिलेशन होगा वहाँ सेट में. सो ए इज प्रीसीडेड बाय ए सुप बी, मस्ट सुप्रीमम जिसको भी आपने डिक्लेयर किया है उन दोनों एलिमेंट्स का, तो ए वो एलिमेंट जो है वो इससे प्रीसीड करेगा. सिमिलरली बी भी प्रीसीड करेगा उसी अपने सुप्रीमम से. ये डेफिनेशन है इसकी, बिकॉज ए सुप इज द अपर बाउंड ऑफ ए एंड बी. ओके, नाउ सुप्रीमम जब हमने कह दिया ए सुप बी इज द सुप्रीमम ऑफ ए, तो आपको पता है सुप्रीमम मीन्स लीस्ट अपर बाउंड, बट फर्स्टली अपर बाउंड की क्लास से वो एलिमेंट चूज होता है और फिर वो जितने भी एलिमेंट्स बनते हैं उनमें से लीस्ट चूज करना होता है. तो ये अपर बाउंड अगर होगा तो अपर बाउंड की डेफिनेशन यही होती है कि एलिमेंट्स हमेशा प्रीसीड करते हैं अपने अपर बाउंड से. तो A must be less than or equal to, या preceded by A sub B, and B must be preceded by A sub B. It's a definition for the supremum. Further, C is any other upper bound of A and B. अगर ऐसा हो कि C is any other upper bound होगा, तो by the definition of upper bound A must be preceded by C and B must be preceded by C. यहाँ से आप कह सकते हैं कि C is an upper bound of A and then C is an upper bound of B according to the order relation defined in that class. Okay, so in this case we can say that A sub B is preceded by C, because जब आप इन दोनों साइड्स का सुप्रीमम लेंगे तो A sub B is preceded by C sub C and C sub C is again आपके पास सुप्रीमम is again सिमिलर एलिमेंट का सुप्रीमम वो एलिमेंट ही रहता है. सो A sub B is preceded by C. ये भी हमेशा याद रखेंगे, बिकॉज वैसे भी हमें पता है व्हेन वी से दैट A sub B या A join B is the least upper bound और supremum of this, तो supremum का मतलब है least upper bound, upper bound में सबसे smallest. तो in this case C अगर कोई और upper bound है इस A और B का, तो obviously ये supremum उससे less ही होगा, तभी ये least बना है. So it less और precede ही करेगा, तो it means that A supremum B is always preceded by that other upper bound. In other words, A B is actually A join B is actually supremum of AB, means least upper bound. Similarly, least upper bound of that thing. Okay, now we will define the infimum of A and B. We say that infimum of A and B is denoted by A inf and B. So in this case, we know that A inf B must precede A and A inf B must precede B. Now again, by the definition of inf, that is called the greatest lower bound, means lower bound है. When we say that it is the greatest lower bound, पहले वो lower bound होगा, तो lower bound है तो obviously that must precede by the element. इसी वजह से हम इसे lower bound कहेंगे by the definition of this thing. ठीक है, so it means that A and B is the lower bound of A and A and B is the lower bound of B. हमेशा ये condition satisfy होगी. And also अगर C कोई और upper bound है, lower bound है sorry of A and B, means that C is the lower bound of A and C is the lower bound of B, then in in that case C must preceded by A and B, means के ये आपके पास greatest lower bound है. वैसे भी हमने define किया that A and B is actually the greatest lower bound. तो जब वो greatest lower bound है तो अगर C कोई और lower bound भी A और B का है तो obviously वो C इससे smaller ही होगा. Okay, so ये भी एक आपके पास property है जो आगे यूटिलाइज कर सकते हैं. सो C must be preceded by A and B. ये जो स्क्वायर्स में मैंने की हैं सारी, इन तमाम को आपने कंसिडर करना है, रिमेंबर रखना है, क्योंकि करना है क्योंकि हमने आगे इनको यूटिलाइज करना है. ओके, नाउ that is C is the lower bound of A and B, then C must precede A and B, because meet B is actually defined as infimum of A and B, means greatest lower bound. Okay, next theorem is let A be a lattice, means we have defined the supremum and infimum over there. ठीक है, the join and the meet have the following properties, और उसमें जो आपके पास join और meet है उनकी ये properties हैं जो ये satisfy करते हैं. First is आपके पास x sup x is equal to x, means ये idempotent property with respect to sup, and this is idempotent property with respect to nth. Next is the x sup y is equal to y sup x, it is a commutative property with respect to sup, and this is commutative property with respect to nth, or join or meet you can say it. Now this is the associative property with respect to join, and this is the associative property with respect to meet. Next is absorption law, and this is x join y is meet x is actually equal to x, and x meet y sup x or join x is equal to x. We need to show these four properties are satisfied. Actually these are 8, but we will prove only 4 because these are the duals of this one, and by the duality we have this opportunity that we can't that we don't need to prove these theorems results if it is a dual of some theorem. So firstly, x sup x is equal to x and x inf x is equal to x. Obviously x sup x is equal to supremum of x and x, this is equal to x, and infimum of both element is again x. If we talk about two elements, then in that case similar elements, immediate, actually this 1 and 2 are the immediate consequences of the definition of infimum and supremum. You don't need to just prove it. Okay, now we need to prove third one, means associative property with respect to join. Okay, for this x sup y sup z is equal to x sup y sup z. Okay, we have to prove that this is preceded by this one and then this is preceded by this one. For this case, first we will prove that x sup y sup z is preceded by x sup y sup z. Okay, now we know that x is preceded by x sup y sup z. How? अब इन जिसको हमने प्रूव करना है, जिस स्टेटमेंट को, उसको माइंड में रखेंगे और उसके अकॉर्डिंग हम यहाँ प्रूव करेंगे. अब x is preceded by x sup y sup z. How? हमेशा x जो है एलिमेंट वो अपने वो खुद और किसी और एलिमेंट के सुप्रीमम को हमेशा प्रीसीड करता है बाय द डेफिनेशन. ये जो सुप्रीमम की डेफिनेशन यहाँ थी, दैट आई हैव मेंशनड इट फॉर यू हियर, that always the case that A is preceded by A itself sup another element. That doesn't mean that we can't take more than one element. Okay, so from here we have used the definition of supremum, that x is preceded by x sup any other element, and here in this case we have taken y union z because y sup z because we need to prove this side. Okay, so x must precede by this thing now, and y is, we can't directly say that y is preceded by this element because it's in the combination of parentheses. So for this we need to prove that we need to say that y is preceded by y sup z, z is any other element, so y by the definition of supremum, and now this element must preceded by x sup y sup z. X we have taken to prove this side. Okay, So from here we can say that y is preceded by this element. Now x is preceded by this element and y is preceded by this element. Then again by the using the conditions in the supremum that I have mentioned over here, we will take the supremum between these two elements, because इस साइड जो आपका एलिमेंट है वो सिमिलर है. सी कंसिडर करें इस तमाम को, ये और ये x sub y sub z, and again here it is x sub y sub z. So it means that x is preceded by some c and y is preceded by some c. Then in that case x sub y is preceded by this element. Okay. Now furthermore, z is preceded by this element, because we need to have z again with that thing. X sub y is preceded by this element. Now we need to consider z as well. Okay, z is preceded by this element y sub z. Again y sub z is preceded by some element x sub y sub z. So it means that फिर again ये वाली side और ये side आपके पास similar आ गई है. So we can say that x sub y sub z is preceded by this element, that is x sub y sub z, and call it equation number A. Now we have shown that x sub y sub z is preceded by this element. Similar on the similar lines, we can also prove that x sub y sub z is preceded by this element. So from A and B, we can say that x sub y sub z is equal to x sub y sub z, or x join y join z is equal to x join y join z. Okay, now the dual of this result is x with the inf or meets statement symbol actually. So we don't need to prove this as it is the dual of this thing, and we will consider duals to be true. Now the fourth one is we need to prove that x sub y in x is equal to x. Actually, what does it mean? It means that you have to show that this x is actually equal to infimum of this element and this element, and here this element is x join y and x. We need to prove this thing, that x is the infimum of these two elements. Now what is the infimum? Infimum means we need to show that it is lower bound. Firstly, we will show that x is the lower bound for these two elements. Secondly, we will show that this x is the greatest amongst the lower bound. So for this case, for the lower bounds definition, now we say that x is the lower bound of these two elements. How? Because we know that x is preceded by this element by the definition of supremum, and x is also preceded by itself. So from here we can say that x acts as the lower bound for this element, and x act as the lower bound for this element as well, for itself as well. So it means that x is the lower bound of x sub y and x. First thing is done. Next we need to show that it is the greatest among the lower bounds. Okay, so for this comparison we need to have a lower bound other than x. So let us suppose that z is any other lower bound of both the similar elements. If z is the lower bound of these elements, so it means that z must be preceded by this element and z must be preceded by this element. We only require this one, so this one is not required, so I'm not going to mention it. Okay, so it means that z is preceded by x. Now z is preceded by x. Actually, what does it shows? This is a again this is a lower bound for these two elements, and this is the lower bound for the similar element, and z is preceded by this thing. So it means that x is the greatest among the lower bounds. Okay, and because this is an arbitrary, so it means that x is greater than any other lower bound. So for here in this case, z is preceded by x shows us that x is the greatest among the lower bound. When we say that x is the greatest among the lower bounds, it means that it is infimum of x and x sub y, and mathematically we can write it as, again its dual is x and y join x is equal to x, and we don't need to prove the other thing because it's the dual.